using Fireblocks. So please, everyone, please welcome Alon, Goltzman. Woo!
Hi, everyone. Okay, so today we'll be going through how to build on Web3 using Fireblocks. Okay, so first of all, who am I and a bit of agenda. So my name is Alon. I'm a solutions engineer at Fireblocks. My work primarily consists of working with customers, helping them with whatever they need when it comes to implementing Fireblocks in their environment, as well as research and creating and improving our existing tools. So as for the agenda for today, we're going to have around 10 minutes of slides, maybe a bit less, and then we're going to have a technical demo. So for the slides, we're going to have a high-level architecture so we can understand what Fireblocks is and what it provides, and a couple of example use cases, as well as after that, we're going to go into the technical part, which is going to be around 20 minutes, which is going to be a workspace overview, and we're going to deploy and interact with an NFT via the API. Okay, so let's get started. So at its core, Fireblocks is a very, very secure wallet provider. But in addition to that, there are a lot of additional functionality and features that we provide, right? So not only is it a very secure wallet provider, you have the ability to basically create and manage policies for your assets. Okay, so you could basically create a policy that says assets, let's say Ethereum, up to $100 are okay to go through, approved automatically or by a human, and above $100, let's say, it has to be authorized by a human being, right? So there's very tight controls, but still flexible in terms of how you can control your assets, okay? In addition to that, every user in your workspace has a role that you can designate. Different roles mean different abilities in terms of what a user can actually do in your workspace. Now, this is very important for security purposes, but just as important as security, we want to make sure that it is very easy to adapt to market conditions or to your demands, right? So, for example, if you currently work on a chain, let's say Polygon, okay, and you want to migrate all your contracts and stuff to a different chain, let's say Ethereum. So we want this migration process to be as simple as possible. So that's something that we do offer as part of the functionality of wallets and the way that the entire workspace operates. In addition to that, we have additional support for features like tokenizations, NFT marketplaces, and so on. So let's take a look at a high-level architecture. Before we dive into that, let's just talk about the tool set that we provide as part of the API. So overall, like I said, we have the API. So it's an open API spec. So if you want to, for example, write the SDK in a different language, you can basically follow the API spec or do direct HTTP calls. So you can do that. We have our SDKs both in Python and in JavaScript, right, that you can very easily integrate into your solutions. The last part that we have as part of what we call general tools are webhooks. Okay, so webhooks are basically the ability to react to things that are happening on your environment. So let's say you get an incoming transaction and you want to update some internal ledger, a webhook is perfect for that. Now, in addition to that, we have EVM tools. Okay, so things that are more directly towards the EVM chains like Polygon, Ethereum, and so on. The first one is the Web3 provider. It is very simple to use it and integrate it with things like Ethers.js or Web3.js. Okay, so this is primarily JavaScript based. We provide a plugin for Hardhat, right? So I'm assuming the majority of you are familiar with Hardhat. So it is very easy, and we will go through it to integrate Fireblocks with Hardhat in a way that basically you can perform smart contract operations directly through your Fireblocks API using Hardhat. The last tool that we want to cover is is what's called the local JSON RPC. So if you want to write in a language that isn't JavaScript, but still have all the functionality without having to implement too much, then we provide the ability to set up a local JSON RPC. Right? So this is an agent that sits on your server and basically receives requests, normal Ethereum or EVM requests, and then forwards them to Fireblocks using the same functionality that the Web3 provider gives. Okay, so let's talk about a high-level architecture. As I said, our bread and butter is being a super secure wallet. So how does that work? There are basically 3 layers when it comes down to it. Okay, so the first one is called MPC CMP. So MPC stands for multi-party computation. It's a cryptographic theory that basically says you have a private key, right? So we all know that we use private keys, but that private key is never stored in a single location. Instead, it is split into 3 different parts or more, right? And stored in different locations. The MPC theory basically provides the basis of this key sharding functionality. On top of that, we have an additional layer called Secure Enclave. Okay, so this is more of a hardware functionality. So the majority of the servers that we currently use have what's called a secure execution environment. So this is basically some part of the CPU that can execute code in such a manner that nothing can access it except the CPU itself. So no one that has any access or permissions on the machine, not even kernel level permissions, is able to see what happens within this secure execution environment. So that combining with the MPC, the fact that it's sharded in 3 different locations, as well as the fact there's this secure execution environment, basically creates a very, very secure setup for your private key shards. The last part on top of that is the policy engine, which we touched on briefly before, with how you can define how assets can come and go out of your wallets. Okay, so how does this come into play in reality when you create a transaction? So you create a transaction, you send it through the API. It arrives into our API gateway, and then it is sent to 3 different locations. 2 co-signers, those are machines that hold key shards on our side, on Fireblocks side, get signed, the transaction gets signed by them, and they generate what's called a partial signature. Since the key is basically sharded into 3 different locations, the signature isn't really complete until all 3 locations sign it. The transaction also gets received by the customer co-signer, so basically the co-signer that houses the key shard on your side. And after some operations there, it might get signed or it might get rejected. Okay, but let's say it was signed. Once it was signed, all 3 partial signatures are then aggregated back to a full signature, with that signature then being sent out to the blockchain itself. And basically the transaction then gets broadcasted. Okay, so that was basically a high-level overview of the architecture, right? So a bit about us as a company. We have thousands of customers, over $4 trillion in assets that we've secured. We're trusted by industry leaders, starting from banks to blockchains, as you can see near, and other industry leaders in various industries. Like I said, you can do NFT marketplaces, you can support blockchain games, you can even support tokenizations, and a lot more. Let's see a couple of use case examples, okay? So the first one is Magic Eden. Okay, so Magic Eden is an NFT marketplace on Solana. Okay, so their use case was they had to provide the ability to create an in-game marketplace for users. They wanted their users to be able to very easily and seamlessly integrate. So with our solution, we help them basically to automate that setup and be able to create a per user, per wallet, per user, per chain wallet for them. So if they wanted to, for example, switch to Polygon, people who develop on Magic Eden want to switch to Polygon, they could do that very easily. Now, the second use case is Flipkart. So Flipkart is an e-commerce application. Their original onboarding user experience basically wasn't suited for users who weren't familiar with Web3 and blockchain technology, right? So as we're blockchain developers, Web3 developers, we know that basically the private key is probably the most important part, and having end users have to manage their own private keys is a very difficult situation, as they can accidentally leak it and result in loss of funds. So basically with our setup, they were able to very easily and seamlessly for the user create wallets for them without having the user to handle any of the Web3 parts. Okay, so those were the two use cases. Now we're going to move forward to actually talk about the technical part. So one second, I'm just going to share the screen. One moment.
So if anyone have any questions regarding Fireblocks, its tool or its application, you are free to ask. All right, there's a question.
Thank you. What is the licensing model of your product? Is it per wallet, per user, per month?
So it's I believe it's per workspace. I'm more on the technical side, but we can definitely get you in contact with someone who can talk more about that. But I believe it's per workspace, and we'll touch on what exactly a workspace is in a minute.
Okay, thank you.
Any other questions?
Anyone? All right, we are good here, Alan.
All right, cool. So let's continue. We'll get started with the demo. Before we do a demo, I just want to go over a workspace and show you the different features and things that we have there, okay? So this is an example workspace. Before I continue, two things that I forgot to mention earlier. First of all, we're sponsoring a $1,000 bounty prize if you build on top of Fireblocks. So you can definitely go with that. And if there are like any questions after the session, you can reach out to us on the channel, on the Fireblocks channel in the events Discord. So now, this is basically your workspace. Okay, so the workspace is divided into, I guess, three main parts. The tabs on the left, the main view in the middle, and the activities on the right, which is also collapsible, okay? So on the right, basically, you'll see any transfers that are coming in or out. So right now, we're using a sandbox environment. So this is an environment we created specifically so that we can, so that developers can basically have a someplace to play around and play around with features, see the workspace, see the console, and figure out how to work with things. Okay, so on the right side, as soon as you create a sandbox, you automatically get 0.1 Goerli ETH incoming. I later did a transfer of additional ETH just so we have it for the session. Okay, but anything that's coming in, coming out, you'll see on the right-hand side, as well as if it's successful or if it failed. Now, on the first time that you actually log into your sandbox, you'll be greeted by this window. Okay, so to use the sandbox, to use the API, you have to create an API user. So this window will basically get you through the setup process for the API user. So you'll just go through here, you'll provide a username, and you'll set up your, and it'll give you basically a private key and an API key. So you'll need to download both of them. I've already done that. I've prepared it in advance so that we can save time in between. But just so you know, that's what you're gonna get. It's important to save the private key. The API key is available post setup. So if you go back to the developer, you can see that I can copy the API key for the user that I've already set up. So basically, we went through the right-hand side. Now, on the left-hand side, you have a couple of tabs. There's a lot of features that we provide. We're not going to touch on the majority of them. The things we are going to talk about is the accounts and NFTs, and maybe a bit about the settings themselves. Okay, so within the accounts, you basically see all your vaults. Okay, so with your workspace can have multiple vaults. Let's say a vault per user, or vaults for logical separation of your assets. Okay, within each vault, you can have multiple wallets, right? So a wallet is basically an address on a blockchain, right? Depending on the type of assets, the wallet can have deposit addresses, okay? So for example, Bitcoin, I can have deposit addresses, Ethereum, I can't. But you can see very clearly the address and get all the information. So pretty much everything that's available on the console UI is also visible on the through the API. So now let's talk about the actual demo that we're going to do. If you go to Fireblocks GitHub.io, you will be greeted by this page. There are two different parts. We're just going to do the first part, which is just creating, deploying, and interacting with an NFT collection. Okay, there are a couple of prerequisites here. You can register to the sandbox here. Okay, and now let's just get started with the actual NFT creation. So as I said before, the majority of this I've already done. I'm just going to run the install of packages. So we need the Fireblocks Web3 provider and the Fireblocks SDK. So this is my setup. You can see the secret key right here, as well as the API key that I saved under text keys.txt. So we're just going to install the packages. Just going to close this off. Okay, so now while this is getting installed, for creating the API user, like I said, we already did that, so there's no need to do that. We're just going to set up the actual SDKs. So depending on what you want to do, what information you want to get, you might need to use the SDK, or you might need to use the Web3 provider. In this session, we're going to primarily use the Web3 provider and the basic functionality of Hardhat. So we're just going to create a file called bkk.js, and I'm just going to paste the code right here. So I assume the majority of you know what this code pretty much says. I'll just run through it very quickly. The first 3 lines are just importing some modules that we need. The fifth line is going to be the absolute path to the private key. Okay, and then the 6th line is going to be just the API UID. The last line is to create the actual SDK. Okay, so the SDK takes the secret key, the API key, and optionally a URL. So if you use the mainnet setup, you won't need to give this any parameters. If you use the sandbox, you will need to provide this specific URL. So sandbox API Fireblocks IO. Okay, now let's go through the first part, which is just creating a vault account. Okay, so all the code here is basically copy paste. There are locations like these where it specifies that you need to put something there instead of what currently is there. Okay, but we're going to run through this, and the majority of them should be fairly straightforward. So this code right here, all it will do is we'll basically create a new vault account. So we're just going to save this and run the code. And what we're going to get is vault ID 1, right? So the vault IDs increment by 1 each time, and they're just basically an integer. Now, how does this look from the console perspective? If we go back to our console and go back right here to your accounts, you can see that you have a new vault account called Treasury. Okay, so before default was vault account 0, it is where my Ethereum is currently stored, and 1 is Treasury, which currently has no wallets in it. The next step is to actually create a wallet. So everything I'm talking about, I added an API reference into the GitHub pages. So you can basically click the API reference, and then it'll take you to our developer portal, which has both the API reference as well as best practice errors, guides for different languages, and so on. So you can go through that if you want as some additional information for you to use. So now we're going to create a wallet. So again, the code is basically copy paste. I'm just going to comment out this code and paste this. Here we need to change the vault account ID. So I'm going to put it as 1, as that's what we just created. Okay, so this basically means create an asset or a wallet within vault account ID 1, and this is the asset ID. So I'm just going to run it for a second. Now the asset ID changes depending on the asset you want to do. Specifically for Fireblocks, we denote ETH_test3 as Guarly ETH. Okay, Polygon Matic is basically Matic. Polygon Matic Mumbai would be testnet. Again, in the API reference, everything is specified there. So you can see we got this address as our Goerli ETH address. If we go to the console, you can see that now under Treasury, we have a new Goerli ETH wallet. And if we click here, we can see that we got the same address as we did in the console output. Okay, now generally for funding your wallet, like I said, as soon as you create the sandbox, it'll deposit 0.1 Goerli ETH. If you want different funds, you'll have to go to the corresponding faucet after you created a wallet and request the funds to be transferred. You can basically run a verify on your balance, or basically get the information about a specific wallet. All right, so for example, let's take a look at the current balance of vault account 0, which is the default one, specifically for Goerli ETH. So if I run this, you'll see it's basically an object with a couple of parameters. The ones that are most relevant for us right now is total, balance, and available, right? So potentially, if you have an incoming transaction, the funds might still be locked or unavailable while the transaction is actually confirming on the chain, or depending on different set of features depending on different settings that you have in your workspace. Okay, so here you can see a 0.69 Goerli ETH. Okay. So now creating the actual NFT collection. So I've already done through this so that we don't have to wait for dependencies, but basically just creating a basic hard hat project. Now we're going to remove the original file that comes with the hard hat project. Okay. Now that we've removed that, we're just going to install 3 packages. So Open Zeppelin contracts for NFT or ERC 721 standard, the hard hat plugin, and data URI that we're going to use as part of the minting script. So I'm just going to run these ones real quick. Okay. Now while that's running, we're going to configure the hard hat so that it knows to use the Fireblocks plugin in order to basically perform all the minting operations. Okay, so if we go in under Web3 Workshop, which is a folder we created for the project, under hard hat config, we can just copy and paste the code here. So what it does is basically when we want to deploy to Goerli, it'll use the ANKR node if it needs to query information, but for the deployment itself, it will use specifically Fireblocks, specifically the sandbox URL to do an API call. Now here we need to give it, again, the absolute path of the private key. So we're just going to copy that and paste it here. And the API key, which again we stored right over here, as well as the ID from the account creation. Now, originally, like I said, we created an account and then we would have funded it, but since creating the sandbox already funds the default vault account, we're just going to use 0 instead of 1, which is the vault account we created. Okay, so basically now the config is done. So when we run hard hat into Goerli ETH, it will basically use the Fireblocks API to perform all the operations. So now let's just copy and paste the actual contract code. So I just named it Robot Doomsday. There's nothing special about the contract. It's just a basic ERC 721. So we're just going to create Robot Doomsday .sol. Just going to create, copy, paste. Like I said before, the Open Zeppelin was for the ERC 721 contract. Okay, so we're basically good to go from that perspective. What we're going to do is we're going to run hard hat compile just to make sure we don't have any issues. You can see 14 files compiled successfully. And now we're going to override the default deploy script, which was basically created for the original lock.sol file. So under scripts, under Web3 Workshop, we have the deploy. It's just going to be, again, a copy paste. So now, once we run an actual deploy, it will, like I said, go through the Fireblocks API instead of going through, a local private key signature. So we're just going to run the deploy now, and we're just going to go to the console. And in a second, we should see a new transaction coming in, which will be the actual contract deployment. So as you can see, we got a new transaction, contract deployment, which has 0 ETH, so we don't pay anything, right, from our default wallet account to the 0 address, right? Because when we do a deployment, we do it technically to the 0 address. When you click it, you have a bunch of information. Okay, so for example, right now the status is confirming, so it'll take 3 blocks until the actual contract is confirmed from our perspective. You can override this. Okay, if you want, there are settings that you can change that will basically mean that less blocks need to be wait before we consider transactions confirmed. We have information about the network fee, about the transaction hash. There's a note that you can pin to transactions and so on. So basically everything here you can take a look at. So now we basically created our contract. Let's go back to the console. So here is our contract. Obviously, if we go to the address on Etherscan, we won't see anything there. Sorry, we will see just the basic bytecode since it's not verified. Next thing we're going to do is we're just going to mint an NFT. Okay, so we're just going to go ahead under scripts, create a new file called mint.js, paste the code. Here what we're going to change is the contract address to the address of our deployed contract. Okay, and an image URL. So there's a list that we have prepared ahead of time for NFTs that you can just use like images. So we can just take one of them and paste it instead of the URL that was an image. Okay, so now again, as the same as before, we can just run the script and it will go through the Fireblocks API. So we'll just run the mint. And it will take a second again until it appears here. During that time, I just want to take a quick look under the settings, right? So one thing we talked about before is the policy that basically can say what can come in or go out, okay? So if we go to transaction policy, for Sandbox specifically, it doesn't, there's no functionality for that, but under the transaction policy, you can basically edit the policy and define it as you would like. Unfortunately, like I said, in Sandbox, it doesn't, there's no ability to actually edit the policies, right? So it's like it says right here. So let's take a look at this, at the contract call we did. You can see a contract call to this address, okay? If we take a look here, you can see there's a lot more information this time around. Okay, so again, the network fee, but we automatically know what method we're calling, right? So we're calling safe mint. We know that this was the address, this is an address we gave it, and this is the actual file that we're going to use. Okay, or sorry, the image. Now, in a minute, it will finish the mint operation, and what we should see is that right here under the NFT tab on the left-hand side, we will see a new NFT pop up. Okay. Let's give it a second. Right, so it finished. You can see that we have one record saying from our default vault account to this address, 0 ETH, and then coming in to the default vault account, we have one NFT. So if we just go out and then refresh the page, you can see that we currently have one NFT. Now it gives you basically information, including an internal Fireblocks ID for the NFT, which network it's on, which standard it is, the contract ID and token ID, right? So there's a lot of information there. The last part, just to round it up, is how do we get the actual information from the API, right? So you might want to get that information for yourself or as part of the operations that you're doing. So I've prepared code for that as well. Again, it's just a copy and paste. What it does, it just gets the NFTs that a given set of vault accounts, right? In this case, it's just going to be 0 owns. So if we just paste this code in and run it, right here on the debug console, you will see we have basically an NFT that was sent in. So you can see the name, you can see the internal Fireblocks ID, you can see where the media is stored. So it's an image, right? So if you click on this and open it up, it'll basically show you the image. what collection is, and a bunch more information, right? So this was just a taste of what's possible with Fireblocks. The GitHub pages are up. You can register for the sandbox and play around with it. The second part of the demo, which we aren't covering, is slightly more advanced, where we show you how to do a gasless transaction, which is more of an advanced feature, right? There's the API reference, and we're on the Fireblocks channel on Discord. If you have any questions, that's pretty much it. Thank you, guys.
Thank you so much. Thank you, Alon. All right. Anyone have any questions? Okay.
Alon, it looks like it's more than just a wallet. You can deploy smart contracts and run transactions. Is that correct?
Yeah.
Okay. And then you can visualize your wallets, the NFTs, and all that stuff. Okay.
Yeah.
Thank you.
Like the base of Fireblocks is the fact that we have a very, very secure wallet. But obviously, what is in everything, and the more Web3 becomes advanced, the more features we want to add in, right? So basically NFTs, we're constantly working on adding new features that customers are looking for.
All right. Okay, any more questions? Okay, cool. One more.
Hi, Alan. I want to know more about gas-free transaction. Can you let us know a little bit about it, like the technical detail?
Yeah. So, you know what, like okay, I'll just do a quick rundown on what is gasless transaction in case someone doesn't know. So basically, gasless transaction is when someone else pays for your transaction. So let's say you don't want to hold Ethereum, you just want to hold USDC, for example. So if you want to do a transfer of that USDC without Ethereum, you can't do the transfer. So a gasless transaction basically says, okay, you don't have to pay for it. I'm going to pay for the transfer of the USDC, but you have to sign it, right? Because it's owned by you. So that's like a very, very high level of what a gasless transaction is. Within the GitHub pages, there's also a more detailed example with like names and stuff. From a technical standpoint, there's almost nothing to do, like to set this up. So real quick, I'll just show you if you go right here. So the entire operation of setting up the gasless transaction, assuming your contract supports it, right, is just to basically right here when you create, this is more of an API standard approach rather than using hard hat. When you set up the Web3 provider, you basically say, okay, listen, this is a vault account ID from which I want you to pay, right? So once this parameter, this gasless gas tank vault ID is specified, any operations that will be done with this specific provider will basically be acted upon like a gasless transaction, with this vault account paying for the transaction and this vault account signing for it.
All right.
Okay, and thank you, Alon, for the walkthrough. I have two questions. First, do you support 4337 account abstraction? And second, can Fireblocks MPC wallet has more than 3 signature, like can be 4 or 5?
Okay.
Thank you.
So, thank you for the question. So for the first part, in the set, like you can do. I personally did 4337, I think it's called, like the account abstraction EIP. I did work with it. It's very, with the Web3 provider, it's very easy to do that. But it is possible to work with that, with that EIP with Fireblocks. The second question, sorry, could you repeat the second question?
For your MPC wallet, in the presentation, you show that there will be 3 signature and combined into a valid signature. Can we have more than 3, like 4, 5?
Technically, theoretically, from the MPC standpoint, I believe you can have more, For us specifically, we set it up as 3. That's a hard limit. I don't believe we have more than that. You could have basically the third key shard. Let's say you want to do API, right? So the third key shard will be stored on the server, but different users will have different keys, right? There will be different set of 3 keys for different users. So if you're a user on your mobile device, you'll have a key. If there's an API user, it has a different key, but they all control the same workspace, basically. If that answers your question.
Yes, thank you.
Regarding the key, if we want to be able to manage the key on behalf of the user, for that third key, how would you do that? Like, would you store it on the server and then have the user just authenticate using a JW, with a Web2 type of authentication?
Yeah, so when it comes down to actual, like end users, let's say, then what we generally suggest is that there's some sort of Web2 authentication on your side. So they they authenticate against your servers. And when they want to do operations, you do an API call with your API user. Okay.
All right. And another questions about building a product on Fireblocks. Do we need like any kind of resource before we build on the architecture, like gas fee? No, nothing.
No, you basically, once you register to Sandbox, you'll get Goerli ETH directly deposited in. If you want other assets, you can just add the wallet and then request from a faucet, right? But the Sandbox is only limited to testnet assets right now.
I see. Okay. So if anyone want to try to build any products, you can do so with in that Sandbox. All right, without costing anything. All right. So I think that will be all. We thank you so much, Alon. Thank you for your knowledge, and I hope there will be someone in here who will won the bounty prize. Thank you so much.
Thank you guys. Good luck.